I want to clarify something before I move on to the next problem, which is what I did there when I used StatCrunch. It was a little tricky of me, so let me go back to it for a second. Okay, right here, when we had to choose about the hypothesis test, we have to make a choice about what the null proportion difference is. For our course, it's going to be 0, but I want you to understand why that is. I just kind of blew past it in the last one. All right, so if you have your null and alternative hypothesis, meaning that P1 is equal to P2, P1 not equal to P2, and the same thing works for less than, greater than. I'm just showing it to you for this example. If you took this top one right here and you subtracted P2 from both sides, just for the hell of it. So you took P2 from here, and you subtracted P2 from over here. What would happen? Well, this part would be equal to 0, right? And then over on the left-hand side, you would have P1 minus P2 is equal to 0. That would be your null hypothesis. If they're no different, then when you subtract them, you should basically have 0. Think about that for a second. Right? If the proportions are basically equal, then when you subtract them, you should have about 0. If they're not equal, then when you subtract them, you should not have 0. Oops. There's the symbol. Should not be equal to 0. Okay? That's why when I was in StatCrunch, down here, for the null proportion difference, I say it's 0, and then I picked a not equal to. We, in this class, are going to almost always pick 0. Okay? All right, so that's why I did that, so in case you're wondering, which means a couple things for us. Oops, let me finish this out. Okay, when I have my hypothesis testing cheat sheet, my inferential statistics right here, I only write one set of combinations. I write P1 equals P2 and so on. You have to know, or you could put on your other note sheet or whatever, that the other option for all of these is P1 minus P2 equal to 0. P1 minus P2 not equal to 0. P1 minus P2 equals 0. P1 minus P2 less than 0, and so on. Okay, so you could subtract P2 from both sides for all of these and make a different form. This is, the ones I've written here tend to be the ones we use when we think of the stuff by hand. The ones that I was writing here, right, like that, tends to be the by computer. Computers don't like other numbers involved. They like 0. Computers, they can handle 0. They're happy with 0, etc. So, oops, hold on. Let me just modify that slightly. There we go. So you have to know for yourself that you could write it either this way or this way. And then if you're curious for the next one, it would be, here, hold on. P1 minus P2 less than 0, like that. Oops. Similarly, I just typed in, while it was paused, greater than 0 for this other one. Okay, so there's your 3 options. You should just know that all those are possibilities, and it's going to continue to be possibilities for the rest of this chapter. So just keep those in mind. Okay, so that's why I did that. And then just real quick at the end, I was talking about how, please keep in mind that even though we rejected the null hypothesis, which shows that there was evidence that there's a relationship between aggression and TV watching, that does not mean, much to the politicians' dismay and parents, that one causes the other. There could be a lot of things that are going on here. Perhaps children that watch more TV when they're young, they're watching more TV perhaps because they have less parental involvement, and maybe that's a lurking variable, right? Remember, correlation is not causation. So just because we showed that there was a correlation, which we did, there's a significant relationship going on here, doesn't mean necessarily that the TV is the thing causing the aggression. All right, then we want to redo steps 4 and 5 using the classical method. So we would again reject H naught, but we have to figure out why. So we would need to come up with our critical values, which is over here on step 4. I kind of have these reversed, but step 4 is over here, and you can see I drew a curve. You would draw it by hand. You wouldn't have a computer necessarily on you at all times to be able to do this. And then to get these values of 1.96 and negative 1.96, you have to remember that with a two-tailed test like this one is, alpha was 0.05. So if alpha was 0.05, then alpha over 2 is 0.025. And then you can go to your table, or you can go to StatCrunch, either way. So I can go to StatCrunch calculators, normal, And I can say I want the area to be 0.025. There it is, negative 1.96. All right, so I just pulled these up. So at the bottom of the normal table, oops, hold on. There we go. So we have them right here, for example. This is a two-tailed test. Our alpha was 0.05, so we want the 1.96, plus or minus 1.96. So that's one way to get them. The other table you're given on all of your exams is the t-table. So if you go to the 0.025 column, drop to the bottom to the z's, that's 1.96. So that's another way. All of those are possibilities. So one way or another, you've got to get these numbers of negative 1.96. So let me write them out. So z alpha over 2, actually plus or minus. So plus or minus z alpha over 2, which would be plus or minus, plus or minus 1.96. So there are your two critical values. So, matter of fact, I'll label those. Those are the critical values. So anything past that is so unusual, right? We're basically saying, hey, I'll take up to 1.96 standard deviations away to either the good or the bad, the plus or the minus. But anything past that is so unusual that you think something's up, and your original supposition that the proportions are equal has to be discarded. Okay, well, our test statistic was negative 4.036. That means that the kids that don't watch TV are aggressive. The difference between the kids that watch a lot of TV and the kids that don't, it's so significant that it's 4 standard deviations away from the mean, which is well past the 1.96 threshold. So yeah, we're rejecting. We're totally rejecting, right? I mean, if nothing else from this course, you should know that if you have a z-score of around 4 point something, you're going to be rejecting the null hypothesis because you're so far away from what you consider to be normal. Just a recap again. You assumed that the proportion of aggression between TV watchers and non-TV watchers is the same, or little and lot TV watchers. You assumed that to be the case. And they were different. One was at 5% and one was at 25%. Look at this, 0.0568 to 0.2488. That's a big difference, but was it big enough to be significant? Well, what you found was the z-score here for how far apart that distance was, which is significant. It had a p-value that was less than 0.0001, so you rejected the null hypothesis, or you can think of it as that 4.036 is so far away from our threshold of normal, usual values, which was negative 1.96 to 1.96. So 4.036 is well beyond that. It's unusual. So we are going to reject the null hypothesis. I think that it is different. The more TV these kids watch, the more aggression they're going to show later in life. Doesn't mean it causes it, but it means there's a relationship, and we're showing it, that it's highly likely that that relationship is true. Moving on to example 3, let's just make sure that we know how to analyze that lovely StatCrunch output that we learned how to find before. Ooh, I better save this. I want to start saving my technology file right now. Chapter 11, technology. All right. Lovely output right here. This is the General Social Survey. It tracks trends in American society through annual surveys. Married respondents were asked to characterize their feelings about being married. A researcher wants to test whether the proportion of females who report being very happily married is smaller than the proportion of males. Sample 1 was married females. Sample 2 was married males. Now, I got to tell you, when I give you a problem like this, I will hopefully at all times give you a hint as to which population was which. So I told you here, sample 1 is married females, sample 2 is married males. When you do it yourself, of course, you can set up whichever one you want. But sometimes in the problems, I'll try to give you a hint about who I want, or maybe I'll just say flat out, make this group sample 1, make this group sample 2, just to make our lives easier for when I have to grade and stuff. All right, so here's the output for StatCrunch and Minitab down here. Now notice, the researcher wants to test whether the proportion for females is less than the proportion of males. So are women more unhappy, or are women less happy in their marriages than men? That's what we want to test. But the computer outputs, you can see it right here. StatCrunch is really easy. P1 minus P2 equals 0. P1 minus P2 less than 0. And then over here, Minitab's a little bit harder to read. They tell you they're testing the difference, P1 minus P2. And then see down here, test for difference right there. See that? The versus less than 0. It's telling you what the alternative hypothesis is right here. Actually, the null and alternative. Hold on one second. Want no fill. That way you guys can see it. Okay? So that's what they're talking about. So there's the alternative and null there, which is a little bit easier to see, or harder to see, excuse me, than StatCrunch, which is way easy. All right, so why is it okay if we wanted to test P1 equal to P2 that they're testing P1 minus P2 equals 0? Well, that's what I was talking about from before. That's what I had to enter into StatCrunch to do this. So if you have P1 equal to P2, you can subtract P2 from both sides. That'll get you P1 minus P2 on the left is equal to 0. If P1 and P2 are truly equal, then their difference should be 0, right? So that's totally fine. Now, how many females were surveyed? That was 423. So look these over, make sure you can see it. There's N is 423 there, total is 423 there. How many females reported being very happy? That was 257. That's your X right there for group 1. That was the females. 257 right there. That's X1 for your females. So the proportion for females is 257 divided by 423, which is 0.6076. Right there, it's in Minitab 0.6076, and StatCrunch isn't giving it to you. So if you got StatCrunch, you're going to have to find it yourself. But you just take 257 divided by 423. All right. Well, how many people total were surveyed? Well, there was 423 females, 366 males. Together, that makes 789. The test statistic. All right, let's circle this sucker in some kind of color. And by circle it, I'm going to put a box around it. Let's see here. Let's do orange, and I'm going to have no fill. Okay. All right, so our test statistic was negative 1.56 or so, which is where in this lovely thing? Oh, look right there. Easy to spot in StatCrunch. No troubles. And then now where is it in Minitab? Minitab doesn't give us quite as many decimal places. There are ways to fiddle with that in Minitab, but I doubt that I will. So you just use however many decimal places you were given in the output that you're told to read on your exams, on your final as well. All right, so then what about the p-value? Well, let's do that in a different color. Let's make it, I don't know, green or something. Well, let me pause and make it green. There we go. I know it was like magic, but there's the p-value, 0.06 or 0.0596, depending on which computer program you're looking at. But I boxed it in green for you. Now use that computer output to perform step 4. Step 4 of the p-value method, of course, because why would you do anything else from computer output? So you would draw this by hand. You wouldn't have, you know, a computer program to do this for you. But you can see I've got my p-value 0.0596, and there's my test statistics. Matter of fact, I should have labeled these. So I'm going to click in here and label them. Hold on. There we go. So you can see that's Z0 right there, that vertical line, and there's your p-value. And yes, you would draw it by hand. You won't have a computer to do it, so just draw a normal curve and fill in the parts. Now, if the researchers set alpha to be 0.05, would the results be statistically significant? And the answer is no, because the p-value is 0.0596. That's greater than alpha, which is 0.05, so we would not reject H naught, and thus that's not significant. I mean, what's significant to us is when we reject the null. We assumed the null hypothesis was true, so not rejecting it is no big deal to us. That would mean that there's not enough evidence to support the claim, many men will be happy to hear this, that females who are married is less than that of males. In other words, that females are less happy in their marriages than men. So there's not enough evidence to prove that, according to this survey, which was a real true survey, I swear. I know, men are rejoicing, saying, see, we told you guys are just as happy as us in our marriages. Alrighty, we're done with that. I'll meet you back here for the next section, which is when we're going to start making a confidence intervals. And we are so using StatCrunch to help us, because look at that god-awful formula. All right, I'll see you then.